So hello, I'm Brett Smith, and I work at SaaS Institute. We're an analytics, AI, and ML company. And I'm leading the effort to modernize our pipeline to meet the Executive Order 14028. So today's plan is to talk about securing the AI and protecting our electric sheep. We make RPMs, OCI images, DEB images, and we ship them to customers. And our pipelines we're adding AI to our pipelines. So we want to keep our sheep safe. So the AI revolution's here, and with it comes new challenges in the form of AI cyber attacks. And as we're using AI to improve our time to market, our bad actors are aggressively using AI to improve their cyber attacks. So at SaaS, we're working to add AI to our pipelines to improve our defenses and protect our electric sheep from the wolves at our door. The AI attack vectors are numerous, and I'm particularly worried about three things. It's the users, the models, and the supply chain. And it starts with the users and over-reliance. And the over-reliance can lead to other problems with the models. We have prompt injection attacks for the models. And if the model has excessive agency, it can lead to sensitive data leaks and then data poisoning, which in turn affects the supply chain. And so what we end up with is a Venn diagram where our attack vectors overlap. And in general, we want to protect these areas to protect our supply chains. So what do I feel is mostly solved? Well, that'd be securing AI generated code. Look, developers write bad code and AI helps them write it faster. At SaaS, we treat all the AI generated code the same as you would any other code. It runs through the linters, the SAST, the SCA scans, and is reviewed by at least 2 humans before it's merged. We treat everything as code, IAC, documentation, source code. It's all treated with a consistent security practice. Education is the key. We want to educate our developers and on the developing risks of AI code and having them secure the security tools. How do we do this? Sneak is how we do this. We use Sneak code, Sneak open source in our IDEs, our CI, and our pipelines. So what keeps me up at night? AI models in the supply chain. How do you test an AI model? So AI models are like grenades. And the only way to test them is to pull the pin and throw them in. Luckily, there's some frameworks that'll help us with securing the AI models. Google recently published a secure AI framework. The conceptual framework is for securing AI systems. SIF is inspired by security best practices and in incorporating and understanding the security megatrends and risks specific to AI systems. SAFE consists of the following 6 elements. So the first 2 are about securing the AI pipeline, right? It's expand the strong security foundations to the AI ecosystem. Basically, apply the same security foundations that you apply to everything else into your AI. And then extend your detection and response. Extend your monitoring, your logging, and your auditing into your AI to protect yourself against the upcoming threats. The next thing is fight fire with fire, right? Use AI to automate defenses to keep pace with the existing new AI threats. And I found this one most interesting, and this is the one we're looking into the hardest, is like, how are we going to use AI to automate our defenses? The defense in depth, again, apply the same security controls to your AI that you would to any other system. And then we want faster feedback loops so that we can react sooner to AI attacks. And then you want to make sure the business understands the risks of the AI systems that you're getting ready to use. There's a couple other tools. OWASP you should know of. The NIST standards are out there. There's a new AI addendum to the SSDF that's in public draft. I've read it. It's pretty good. But the ones you probably don't know about are the MITRE Atlas. And the Atlas Matrix shows the progress of tactics used in an attacks has columns from left to right. It's a website, and you go and you click on the tactic, and it tells you how that they're going to try and attack it. And then the Atlas data is a Git repository full of data that helps you research and navigate through artificial systems. It's a really new, good thing that I've found that's helping us at SAS figure out how to secure our supply chains. So what are we worried about? Well, we're worried about the prompt security. You know, the prompt's usually the way users interact with the models, and it's a way for attackers to manipulate the model. And by evaluating the input from the prompt, we can ensure that the model is not being manipulated by the attacker. So you want to do your due diligence with your inputs to your model. The data. This is probably one of the most important pieces, is that you want to protect all training, testing, fine-tuning, and aligning data from unauthorized access and modification. You're using this stuff to train your models, and you're using this stuff to test your models. It cannot get compromised. You need to continuously monitor the confidentiality and integrity of the training data. And then you consider using securely, well, you should securely store all of the data and maybe keep it for future reference if feasible. You should, I mean, we've gone as far as, it's not just SHA sums, I've gone as far as thinking about maybe we cryptographically sign this stuff. So at SAS, we take securing our code seriously. Well, you should take, we also include AI models, model weights, pipelines, and reward models, and any other AI model elements in our security measures. We follow the principle of least privileged to minimize direct access to the AI models and model elements regardless of where they are stored or executed. The plan is to store all AI models, model weights, and other AI elements in separate locations. I'm also considering possibly removing human access to the model weights, but we'll see. This is all taken straight from the NIST addendum. Confabulation, hallucination. So the model didn't know what it was doing, so it made something up. This is happens a lot more in large language models, and because they're trained on large data sets and they can produce false or misleading predictions, known as hallucinations. The problem is that the model will tell you that it is true in a way that you believe that it's true. These can be caused by bias in the training data and errors in the model architect or other factors. To mitigate risks of hallucination, we need to carefully curate the data, test the models on a variety of inputs, and monitor the model's performance over time. So this isn't rocket science. Sysadmin 101 goes a long way in securing your environment. If you apply the same things that you apply to your current environment as you're trying to, like for us, trying to meet the executive order, as long as we extend that into the AI systems, we get the same type of results. You want to limit access. You want to think about air gap solutions. Well, I'm going to cover some other things in another slide that'll be interesting. So instead of using a large language model, I'm starting to research using smaller, concise models. And then the small models are trained on highly curated data sets. They're less likely to run amok. With an open source tool like LangChain, we can link a bunch of the small models together to create a workflow that is concise. There's drawbacks. The weakest link breaks the chain. If the first model thinks the tree is a beaver, the rest of the models will think the tree is a beaver. And I don't think we want a forest full of beavers. So we have to be diligent with how we train the models and have a plan for if things go wrong. So the main thing we should do is excessive agency is the danger. So we need to limit your permissions, right? And we limit the permissions of AI models to only what they need to do their job, right? I suggest that we use read-only permissions whenever feasible. I mean, if the model just needs to slurp data to get its job done, then that's all it should be able to do. We're planning on sandboxing, and sandboxing is a good idea. And part of sandboxing is containerization, which is also a good idea. being immutable, containers are immutable, and this helps us with our verification and validation of the pipeline. And then we run our pipelines in Kubernetes with a very limited network access. And we do the same thing for our AI model pipelines. Look, just assume things are going to go wrong, right? Models make mistakes, and we need to anticipate the mistakes and have a plan to deal with them. Again, limit permissions and access, and because a model with delete permissions is probably not a good idea. The model could run amok and decide to just delete stuff out of the database. Wrapping up, we want to talk about defense in depth, and basically you just need to have a lot of security layers and protection controls in use. Basically, this is how I look at it. I've got enough gremlins in my pipeline, and the last thing I need is a sentient, non-deterministic gremlin running amok. So using layered approach to security is the way to reduce the risk of AI models going rogue. So that wraps it up. I'm Smitty, and I'm afraid of robots.